Hello everyone, welcome to the control system. This is part 4 of lecture 6 on state space representation, and in this section you will learn how to do numerical integrations in MATLAB. Okay, so to do a numerical integrate in MATLAB we can use ODE45. So it's based on Runge-Kutta method. So you need to, in MATLAB, you need to specify the output t and x is a state, and the solver. So this solver will solve the equation for you. And in this, you need to specify the models, uh, the time interval that you want to integrate, and the initial condition. Okay. So let okay. So we will do a little bit of demo, but we consider a very simple example. Basically, only the card with the mass and connected to the wall by the spring, and we have the input u like this, and the state space equation can be found like this. We already did a lot of example, and you know how to get this model by yourself. Okay, so k is a spring coefficient, m is a mass, and u is the input. Okay, so let's just do it in MATLAB right now. Mhm. So in MATLAB, I should create one folder. Okay, code demo. So I want to go to this folder, code demo, and create a new script. So this script is a main script. Okay, and so the main script first clear CLC, and then so as you remember, we need to specify the solver. In order to do the numerical integration, we can use this one, ODE 45, and then so this is the function. So I want to have the model, okay, and then t spans and initial conditions. Okay, so I need to specify what is the t spans. T span. So I want to integrate from which interval? Let's say from 0 to 10, 0 to 10 seconds, and initial condition is, so our system have two uh, state variable, right? So there should be 0, the displacement and also the velocity, and the models. So the model, we need to create different functions. So this handle function, this add right here, will call that function. Okay, so let we have to create the model, state space model. I want to create, yeah, one more file called, let's say, model, in the same folder. Okay, it have to be the same folder. So I need to create a functions, and the dx is the output for the model, the name of the function, and the input is t and x. Okay. Okay. So our form is dx equal ax plus bu. Okay. Ax plus bu. So we need to specify matrix A. So what is matrix A? From the previous model, if you remember. So with a matrix 2 by 2. So this is 0, and then 1, and then minus k over m, and 0. Okay. And we need to specify what is k, what is m. So k is damping coefficient, let's say 0.1 for the demonstrations, okay? And then m, let's say 1 kilogram. So we have a already, and then we need to have b. B equal, it's also, not also, it's a 2 by 1 matrix, 0 and 1 over m, right? So m is 1. After that, we need to specify dx equal a times x plus bu. But what is u? So let's say u is an input, right? For example, I want to have the constant input, so I just set u equal 2. Okay, so this is the model, and then this function, we'll call that models. Okay, all right, so let's run. So okay, it's already run, it's very fast. So this is the data of the state. Okay, so position, the first one is a positioned, and the second one is this one is the velocity. So we want to plot it. Okay, let's plot the data. Okay, plot. So I want to plot the time, and I need to access the first column, right? The first column of this x. So I take all the row and the first column. Okay. So this one is a displacement. Boom. Okay. And you can also plot the velocity as well. Let's say you want to plot it in the same axis. In that case, you need to use Holland plot. You need to plot with t and together. Okay, all the row and the second column. Okay, and then you need to put some legend. The first one is the displace. How to spell displacement? Okay, placement, and the second one is velocity. Okay, let's run. So this is how the state evolve if you want to integrate from 0 to 10. So let's change this constant a little bit. Okay, let's say this is 0 and then the input is only 1. Yeah, from 0 to 10, it just go like that. You can also change the input if you want. Let's say you want the input to be a sine wave. Okay, so sine wave is a function of time, and you want to integrate from 0 to 100. So run. Okay. This is how it look. So this is the displacement, and this is the velocity. So this is, we don't have any controller. We just know the initial condition of the state at t equal to 0 and the input. Okay, input from t equal to 0 until t larger, and so on. If you integrate from 0 to 100, it means you have input u until the time t equal 100 seconds. Okay, this is quite small. Let's say k equal 1. What's gonna happen? Oh, yeah, it keep oscillating like this because we only have the spring. Okay, so it keep oscillating. So if you put the damper into the system. So at some time in the futures, uh, it will be die out. So it will come back to zero. But in this case, we only have the spring, so it keeps oscillating. This is how you do numerical integrations in MATLAB. So you use ODE45, the solver, you specify the models, you specify the t-span, the time interval, and the initial condition. For the model, you have to write another function in the same folders, okay, like this. Dx, the model. This is the name of the function that you call it. It have the function of time and x, okay, and you need to specify the parameter k, damping coefficient, the mass, the input u, okay, and matrix A, matrix B. The output is dx, and then you can plot. Let's say if you don't remember how this ODE work, or you forgot some functions in the plot, okay, and sometime, for example, you have this axis, you want to label this x, something you want to label y, or you want to know what is ODE 45. In that case, you can go to this section. Okay. This is a search. If you get stuck, you can just search here for the MATLAB function. Let's say you don't know what is the plot, okay, then it will pop up. There are many kinds of plots. So if you are interested in 2D plot, just go to this. See, there are many example to get started. So you can search through this. Okay. The same way as ODE 45. Let's say ODE 45, and then yeah. So you can have this function. And also there are many examples. All right. This is very useful if you want to do numerical integration of a nonlinear function. And you can also do this in Simulink, okay? In Simulink, you can, let's say, in the Simulink library, in the control system toolbar, you can click on this, and then in this section, see, there are many blocks that are available for you. So this block is a time varying state space system. Okay, you can have you just input the model, I mean the matrix A, B, C, D, the input U, and you will have the output dx, x, and y automatically using MATLAB solver. Okay, or not MATLAB, Simulink. Okay, so if you have any question on this section, you can drop the message in our chat group, and then I will respond anything that is unclear. Okay, thank you very much.